Hey guys, welcome to my YouTube channel. As we are still continuing the kidney disease detection project, this is where we use AI to detect the presence of kidney disease in the patient. We know if you look at the introduction, you know that kidney disease is a situation when your kidney cannot filter the blood well. It doesn't remove the filtrate from the blood. That's when your kidney have infected with kidney disease. Is a serious health issue that affects millions of people worldwide. It's a serious that can lead to end of renal system and the treatment, death, or earlier detection of this disease is crucial for successful treatment. As I told you earlier, the objective of this project is to develop a system which is going to the objective of this project is to develop a reliable and cost-effective method for the detection of kidney disease using AI. The project aims at leveraging large data set of clinical and damage information to the train machine learning prediction of the kidney disease. As we know, we cannot get the sample. We have to get the sample from the patient, and that's why we have to get the blood sample, pressure, urine test, among others. That's why we need this project to be implemented. Then the background of kidney disease detection project, we know that kidney disease is also known as renal disease. It's a progressive condition in which a kidney loses the ability to function properly. To function properly, as I had explained it earlier, that the failure of the kidney to filter the blood clearly, and the filtrate remains in the blood. Earlier detection and proper management of kidney disease are crucial for providing patients with outcome. Then the literature review here, under this section, we are looking about the unsupervised and machine learning, unsupervised and supervised machine learning techniques. Under supervised machine learning, it involves training a model using a labeled data set, where the model is provided with both the inputs and the desired outputs, and then uses this information to make a prediction on the new unseen. Since my model is going to be using supervised learning techniques, I decided to use random forest. Here, random forest is used for classification to predict whether an individual has the data as a disease or not based on various features such as age, blood pressure, glucose level, and others. The algorithm built multiple decision tree and aggregates their prediction to obtain a more robust, accurate prediction between the features. Then under unsupervised learning technique, unsupervised learning involves training a model using unlabeled data set, where the model is only provided with inputs and must learn to find the patterns or the relationship between the provided data. Then under unsupervised learning technique, they are there, but my project didn't support any unsupervised learning technique. I used random forest because random forest can deal with both linear and non-linear, that relationship between the features in the data. Then under methodologies, these are the steps which are going through to implement the model. We have data collection. Data collection, like, it involves the steps of getting data to be fed into the machine. This involves getting the blood pressure, age samples from the patient. Then data pre-processing, this involves removing missing values or incorrect or inconsistent in the data set obtained. Then data evaluation, we are trying to evaluate the performance of the model by calculating the precision, accuracy, F1 score, and among others. Deploying, it involves deploying our model so that it can be fully functioning properly. Then the factors considered when selecting data sets have quality, then quality, relevance, variability, size, and quantity. If I start with quantity instead of quality, some models need a large data set compared to others. Relevance, the data should be relevant for its use. Variability, there should be a difference between the collected data. Then size, the results and distraction, evaluating the performance of random forest in the detection of kidney disease, evaluation, mass research. These are the ones which are to be calculated to evaluate the precisions, the accuracy, the F1 score. The results obtained, we got the precision as 94.7%. Then the recall 94.7, accuracy 96.0, and the accuracy it was 90.7. Thank you for listening. As we are about to deploy this model, it can be used and it can be sensitive.